Good morning. Welcome back in lecture number 6, crystal structure. In this lecture, we discuss about axis of symmetry, 4 axes of symmetry. What about number of rotations? What is its mathematical expression? All these things we discuss in detail. First of all, we see what is axis of symmetry. Axis of symmetry is nothing but, or it is also called as axis of rotation. It is nothing but an imaginary line passing through the crystal, such that when crystal is rotated about that line, it represents the same appearance more than once in one complete revolution, that is in a rotation through 360 degrees. The imaginary or imaginary line passing through the crystal, this is said to be axis of symmetry. I mean, if the crystal is rotated through this imaginary line, then it represents the same representation more than once in one complete revolution, that is in one rotation through 360 degrees. Such a line, such an imaginary line, is said to be axis of symmetry or axis of rotation. There are 4 axes of symmetry. On the rotation about the axis, if same phase or same view occurs twice. How many times? 2 times. Then such an axis is termed as, called as dyad axis. What? Dyad axis. Same faces or same view occurs how many times? 2 times. Then such axis of symmetry is said to be dyad axis. View occurs how many times? 2 times. Then angle of rotation is what? 180 degree. That is, formula is n into theta is equal to 360 degree, where n stands for number of rotations of the crystal, theta through which degree? Total 360. So whenever n into theta is equal to 360 and theta is given here 180, because twice it is repeating, so theta is what? 180. Half of 360 means 180. Where n is number of rotations, n into 1 theta 180 is equal to 360, therefore n is equal to 360 by 180, in the sense what? 2 rotations. Number of rotations is 2 whenever the axis is termed as dyad axis. Now what happens about 3 rotations? We see now. On the rotation about the axis, if the same faces or same view occurs 3 times, in previous case it was 2 times. Now same view occurs 3 times, then the axis is termed as triad axis. Dyad axis previous, this is what? Triad axis. In this case theta is 120, n into theta 120 is equal to 360, therefore number of rotations is what? 3. 360 divided by 120 degree is equal to 3. Means whenever same view occurs 3 times, whenever rotated about the axis, crystal is rotated about the axis, then number of rotations is what? 3. Now let us think about 4 rotations. 4 axis symmetry. We say tetrad or 4-fold axis also. What we say? 4-fold axis. On the rotation about the axis, if the same faces or same view occurs 4 times, the axis is termed as tetrad axis, or it is also called as 4-fold axis. 4-fold in the sense 90, 90, 90. How many times? 4 times. So n into theta is equal to 360. Here theta is 90 degree. Therefore n into 90 is equals to what? 360. So it is 360 by 90 in the sense 9 for the 36. That is 4 rotations. So whenever the same view occurs 4 times, whenever the crystal is rotated about the axis of rotation, then full number of 4 rotations is what? 4, called as tetrad axis or 4-fold axis. Then now let us turn towards, after that 4 we get 6 rotations. On the rotations about the axis, if the same faces or same view occur 6 times, then the axis is termed as hexad-axis or 6-fold axis. 4-fold axis, 6-fold axis, like n into theta is equal to 360. So n into 60 equal to 360, therefore 360 by 60 is equal to 6 rotations we obtain. So whenever 6 times the same view occurs, number of rotations is 6. Center of symmetry. What is center of symmetry? It is an imaginary point. Center of symmetry is what? It is an imaginary point in the crystal that any line drawn through it intersects the surface of the crystal at equal distance on either side. From that line, every point on either side of the line is equidistant. Such a symmetry is said to be center of symmetry. Now, what is point group? Very important concept. Point group and space group we are discussing. In crystallography, a crystallographic point group is a set of symmetric operations. What is point group? Set of symmetric operations corresponding to one of the point groups in 3 dimensions, such that each operation would leave the structure of the crystal remains constant, unchanged. Crystal remains unchanged. There is no change in the crystal because of these operations. Such a symmetry operations, set of symmetry operations is called as what? Point. That is the same kinds of atoms should be placed in similar positions as before the transformation. The position of the crystal before transformation and after transformation is the same. Is same, or we say similar. Now let us turn towards space groups. The repetition of an object in crystal is carried out by operations of rotation, reflection, or inversion and translation. Point groups are consistent combinations of rotations and inversions that can occur in crystals. The possible translations that can occur in crystals produce the 14 Bravais lattice. or space lattice. I mean, if we combine the operations of rotation in an inversion with the translation, we produce space groups. Now remember, there are 230 different crystallographic space groups, and each one gives the fullest description of the symmetry elements present in a crystal possessing that space group. Got it? You see now what are the types of lattices. Basically, you remember there are two types of lattices: primitive lattice, or simple we say. Second one is what? Non-primitive lattice. Second type is what? Non-primitive lattice. Then question arises, what is meant by primitive, what is meant by non-primitive? Is it correct? Lattices are either one is primitive or second one is non-primitive. Now, what about primitive? One lattice point per unit cell. Primitive lattice possesses one lattice point per unit cell. And in case of non-primitive, for example, double, triple, etc., more than one lattice point per unit cell. There is multiple lattice point per unit cell. So, such a lattice is said to be non-primitive. Whenever multiple lattice points are there, non-primitive. Only one lattice point per unit cell, that is primitive. See, I will show you figure of primitive. Here primitive, only one lattice point. This figure you carefully see. And how to obtain the number of lattice points? It is given by the mathematical equation n is equals to ni plus nf by 2 plus nc by 8. Then you may ask, what is ni, what is nf, what is nc? So you observe this figure first. Green color is shown to show the points in the interior. Red color is shown to show the points on the face, or mean surfaces or faces. And the blue color you see is going to show the points on the corners. You observe this figure carefully. Then let's turn toward here. F stands for interior, I stands for interior, F stands for face or surface, and C stands for what? Corner. Where Ni, this Ni is the number of lattice points in shell interior. Nf, number of lattice points on the shell faces, shared by two shells. Nc, number of lattice points on the shell corners, shared by 8 shells. So in this way, by using this relation, one can easily obtain the number of lattice points easily. Then, the remaining matter we discuss in next lecture number 7. Thank you.